Hello everyone, welcome to your first week in EEE153 Computer Organization and Embedded Systems 1. This week we are going to have an introductory discussion about concepts that you need to understand before we go to deeper discussions in the next succeeding weeks. And these are the concepts that we are going to discuss. We'll start with the computer systems. Computer systems, or simply computers, are machines that were invented to help make the thinking work easier and faster, like solving a number of equations, tracking information, or analyzing information. They were used to manipulate information without going through the tedious paper computation. When you hear about computers, you may usually think of your desktops and laptops, but nowadays, computers are also on watches, phones, tablets, cameras, cars, TVs, gaming consoles, and some of our day-to-day appliances like refrigerators, washing machines, and many more, though not all of them can do what a desktop or a laptop can. But there's another type of computer that plays an important role in our lives today, especially when we use the internet, and these are the servers. Computers are all around us. It comes in different forms and sizes and are used in many different applications. But what makes a computer a computer? From early computing machines to the latest computer system that you know, all of them can perform four major tasks. They take information in, store them as data, process them, and then output the results. That's what makes a computer a computer. Input is when a computer accepts digitized information from the user or the environment or from another computer. Store is when a computer saves this digitized information in its memory to be processed or output later. Process is when a computer manipulates this information according to a list of internally stored instructions in the computer's memory. And then output is when a computer shows the results back to the user or the environment. So how does a computer do these tasks? To be able to do these tasks, a computer needs hardware and software. Hardware is the physical component of a computer where data can pass through as electrical signals. Any part of a computer that has circuits, chips, wires, plugs, speakers, etc., and all the parts of a computer that you can touch and see are its hardware. Whereas the software is the set of instructions that is read by the computer to control its hardware on how it will transfer and manipulate the data. The hardware and software cannot work without the other. Let's look at each of them in more detail. The four major hardware components of a computer is strongly based on its four major tasks. It has at least one input device, at least one storage memory, at least one processor, and at least one output device. Let's look at input devices first. Input devices or input peripherals are hardware devices that users or the environment can interact with to provide information or additional instructions to the computer. User input information can be a press of a button, the location of a pointer, a touch on the screen, an audio, image, or a video. Devices like sensors can also gather information from the environment and provide them as input to a computer. Input devices takes in information from the outside world, accept them as raw data, and then translate them into binary data which the computer can understand. This binary data is then manipulated in the processor or is stored in the memory to be processed later. On the other hand, output devices or output peripherals are hardware devices that receives binary information and converts that information to a form that is readable to humans or a form that gives action to the environment. User output information can be light, sound, image, or signals to control a motor of a wheel, a robot leg, or a robot arm. Next is the Central Processing Unit, or simply processor. Processors are integrated electronic circuits that contains many circuit blocks that perform different operations that can manipulate data. However, even if data goes into the processor would not know what to do with it. To be able to manipulate the data properly, it needs instructions that will tell which operation to use and how data is transferred from one block to another. Processors are generally composed of the control unit and the data path. Inside the data path is the arithmetic logic unit, or ALU, which contains several functional blocks for performing actual operations on data, like adders, multipliers, FFT, shifters, comparators, and many more. Also, inside the data path, there is a register block, which is like a small size memory where the ALU saves all the data needed during the processing for easy access. There are many ways on how the ALU can process data and how the ALU and registers can exchange data during the processing. So, to be able to properly process a data, the processor needs a control unit that controls the flow of data exchanges in the data path and selects the correct operation inside the ALU. The control signals that the control unit outputs are based on the instruction that the processor receives to manipulate the data. So where does these instructions come from? The instructions and data used by the processor are both saved in the memory. Like the processor, the memory is also an integrated electronic circuit that is capable of storing information. Memory can be either volatile or non-volatile memory. Volatile memory loses its contents when it loses its power. Computer RAM is an example of a volatile memory. This is why if your computer freezes or reboots when working on a program, you lose anything that hasn't been saved. So why do computers use RAM? Because they respond faster. So any data that you are currently working on are transferred to RAM for easy and faster access. In computers, volatile memory is used as the primary storage or main memory. On the other hand, non-volatile memory are those that keep its content even if its power is lost. These are your hard drives, flash drives, SD cards, and many more. In computers, they are used as the secondary storage. Accessing the secondary storage is much slower than the main memory. So this contains the program or data that are not currently being used or those which are not accessed frequently. The memory is like a library of binary information, and each binary information has an address. You can access the data by first searching for its address, just like a call number of a book in its card catalog. In the previous slide, we mentioned that the instruction used by the processor or the data that is being manipulated by the processor are both stored in the memory. I think you may all know now that the data stored in the memory may come from the received information from the input device or the resulting manipulated information from the processor that is ready to be transferred to the output device. The set of instructions stored in the memory together with some of the data are the software or program that we install in our computer. The software is what enables the computer to perform specific tasks. This includes your system software like Windows, Linux, and Mac, and your application software like internet browsers, Microsoft applications, and many more. Software programs that are stored in the memory are in the form of a machine language composed of ones and zeros. Developing software programs using binary machine language is just too confusing. So to simplify the development of softwares, assembly language programs were used starting in the 1950s because they are more readable to humans. Assembly languages can be directly translated to binary machine language using an assembler. However, other higher level language programs emerged during the late 1950s, which are much easier to use. All software programs today are all developed using a high level language program like C, Python, Perl, Ruby, Java, and others. But this type of language program is not understandable by computers, and they are difficult to directly translate to binary machine language. So, a compiler is used to translate the high-level language to assembly language first, and then an assembler is used to translate the assembly language to binary machine language. So now that you have your hardware, which composed of your input and output devices, processors, data path and control unit, and memory, and your software, which includes operating system softwares, application softwares, compilers, and assemblers, how do we make sure that they are always matched together? When a software developer creates a program, does he need to know how the hardware was built? Do the same people who build the hardware needs to be the same people to develop the software that runs in it? The answer is no. So how do we link the hardware and software together? We link them together through the instruction set architecture, which we also refer as the computer architecture. By knowing the computer's architecture, software developers can create softwares without knowing how the hardware was built. On the next video, we are going to discuss further about computer organization and computer architecture and the difference between both terms.